other one also.
I recorded the other one though.
No, the other girl. Yeah.
Sarah.
You know. Opposite guy.
Okay. Anyways, for just a quick recap because I forgot to press the record button, guys. Once again, I want to mention that for anything that is considered an acid is because they have H plus ions being dissociated into the water. For anything to be considered a base is because they have OH ions dissociated into water. A pH scale starts from 0 to 14. The lowest pH scale will be the most acidic. The highest pH scale will obviously be the most alkaline, whereas 7 is considered to be neutral. The first thing you need to remember in this chapter here is MASH, guys. Metal plus acids is basically going to form salt and hydrogen. You can see that these are the common examples that you'll have for different types of acid forming with different types of metal. If I have a sulfuric acid, I'll generally form a sulfate salt. If I have hydrochloric acid, I'll form a chloride salt. And if I have nitric acid, I'll form a nitrate salt. Most importantly, I would say is this part here, right? As long as water is not formed, it's not considered neutralization. And that's a quick summary of whatever I forgot to record just now. Nope. Just in case. Okay, next we move on to acids and base, which you notice here, guys. In terms of acids and base, whenever I have alkali and acids combined together, obviously water will be formed, right? And because water is formed, then obviously this whole scenario here is when we consider it as neutralization, guys, because of the presence of water as one of the products. But ultimately, the salt will also be formed as well, right? Once again, they highlight that for anything to be considered a base, the hydroxide ions must be present. Neutralization will always produce salt and water. This is a must. Yeah, and metal oxides and metal hydroxides are examples of soluble base, guys. Once again, we talk about metal oxides here, guys. If non-metal oxides, what are they considered? Like, for example, sulfur dioxide, a non-metal and an oxide combined together. What is it called? What are they considered? So we have two types of oxides, right? Metal oxides or non-metal oxides. Can someone tell me what are non-metal oxides considered or not in terms of acids and bases? It will be acidic, right? Non-metal oxides, for example, sulfur dioxide is considered to be acidic. And obviously, every time we have metals that are oxides, they will always be it will be more alkaline. That's why the whole periodic table is built upon that, right? The alkali metals are on the left side of the periodic table. In your view, this side of the periodic table, right? It will be alkali metals, and everything on the left is considered to be everything else, right? So remember, guys, whenever you see the word metal oxide, automatically you must remember that it is considered a base. Then metal hydroxide, no need to say because you can literally see the word OH here, right? So then this one is obviously a base. For what you should know now, metal oxides and metal hydroxides are considered to be soluble bases. The next keyword that you should remember in this page here is basically Boss, right? So we have MASH just now, and right now we have like pause, but Boss, Boss. Base, acid, forms water, and salt. Remember this also extremely important. You will be tested on this. Okay? A common example of acids and base is basically this one. You can see here once again calcium oxide, which is going to be a base, formed with sulfuric acid, right, which is obviously the acid, will form water and calcium sulfate. It's very straightforward, right? It's always going to be the metal part, combining with whatever that is not the H plus, right? Combining with whatever this is, these two will form the salt, guys. It's quite straightforward. This chapter here is really considered to be one of the easiest chapters there is, and because of that, you should not be losing marks, guys. You just look at the pattern, then you'll most likely see what's going on. Okay, and once again, Because you have different types of acids, you'll form different types of salt, right? Hydrochloric acid, you'll form a chloride salt. Sulfuric acid, you'll form a sulfate salt. And nitric acid, you'll form a nitrate salt here, as you can see. And once again, the H2O is present because this is neutralization. Yes, everyone? Anyone's got any questions for this part here? Very straightforward, nothing much to explain here. The final thing that you should know of, not really the final thing, last part that you should know of, in terms of acids and the different components, is basically these acids plus the carbonates here. For acids and carbonates here, because there is CO2 inside, guys, basically what's going to happen is the byproduct of any carbonate plus acid will always have the carbon dioxide inside. It will have the carbon dioxide inside, guys. So from here, you can see that the salt and water still remains. But the only difference for carbonates, one way I remember this, guys, because carbonate, there's literally CO2 inside, right? You see, like this one here, there's CO2 in this CO3, right? You have to remember that it forms the CO2 ultimately, guys. Meaning to say, whenever you see the word carbonate, you should think about CO2, or as soon as you see the word equation CO3, you should remember that the product will form carbon dioxide, guys. Extremely important. You will be tested on in your exam in this scenario here. Right. And of course, once again, the salt that is produced is the same thing once again, right? This Zn and this NO3 here will combine together to form the salt. Byproduct of carbon dioxide because of carbonate here. Yes, everyone? Okay, Can, everybody? Right, and once again, these are the examples of type of acids that will produce the different types of salt. Once again, magnesium chloride, magnesium sulfate, and magnesium nitrate. Okay. And the trend will always be the same, H2 and carbon dioxide, H2, carbon dioxide, H2 and carbon dioxide. Yeah, very straightforward. Please let me know if you have any questions. Now, in terms of color indicators are indicators where we determine whether something is going to be acid or alkali. The most common indicator that everyone knows of is basically going to be litmus paper. In general, guys, right now, this part is the annoying part. This part is the annoying part because you have to actually remember what color the acids will produce based on different indicators. But in general, guys, red color is going to be acids and every other color is going to be alkali. In terms of litmus paper, red will indicate that it's going to be acid, blue will always be alkali. Thymophthalate, or however you pronounce that, is thymophthalate, right? Or however you pronounce that, it will always be colorless, whereas the alkali will be blue. For methyl orange, guys, it will always be red. What? It will always be red and the alkali will be yellow in color, guys. You have to remember this. On top of these three things, there is one more thing which is going to be called the universal indicator. For the universal indicator, this is I would say one of the easiest to remember because the pH literally starts like the rainbow. I got my battery is running off, I think. Just in time. Guys, you remember the rainbow color, red, orange, yellow, blah, 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 right? Then you kind of remember the pH scale here already, guys. But ultimately, once again, the red will be the most acidic and the blue, the dark blue into purple will be the most alkali. Okay? Yeah. Anyone got any question for this part here? Phenolphthalein, yeah, I think so, but
Teacher, how do you do the phenolphthalein?
Okay, and one more thing, guys. Oh, what do you want to say again? Oh, yeah, one more thing I want to mention, guys. In terms of whether something is a strong acid or something is a weak acid, this is because of the dissociation of the H plus ions, guys. let's say, for example, we look at two examples. Let's say hydrochloric acid and the other one, what's the other one again? Shit, I'm having brain jam.
Sulfuric acid.
No,
Is it an acid or not?
it is an acid. What's it called again? One of the, wow, shit, I'm having brain jam.
Is it the organic one?
Oh, yeah, organic. What is it called again?
OOH3. No, HCO.
Wow, I'm having brain jam. The organic acid, which was known as,
I forgot the name.
shit, I also forgot the name.
It's like NCOOH3, and then you have to take away the.
What's it called again? There's literally a whole chapter in this. I was talking about it the other day, which I can't remember right now.
The search of organic acids, and then you just say name of it.
Cannot remember the name. That's the problem.
Maybe you like.
Carboxylic acid. God damn it. Yes. Okay, guys, listen up. The difference between carboxylic acids and the hydrochloric acids is because for hydrochloric acids, guys, what happens is as soon as you put hydrochloric acid into water, right, the H plus ions fully dissociates into the water. Meaning to say, right, by right we have HCl, right? As soon as I put it into water, this H plus fully dissociates into H plus, right? And then this Cl will turn into Cl minus, right? But because this thing readily leaves the Cl, this HCl is considered to be a strong acid. Whereas for carboxylic acids, guys, because it is actually a reversible reaction, meaning to say the H plus, right, could release into the water and then it could combine back with its partner. And because of that, it is considered a much weaker acid, guys. For what you should know right now is that as long as they have full dissociation, I mean, you say the concentration of H plus is damn a lot, right? That is considered to be a very, 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 very strong acid. And of course, the exact opposite will be true as well. If I have very, 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 very little H plus ions in the liquid or aqueous solution, then it will be considered to be an extremely weak acid, if not a base. Guys, get what I mean, guys? I want to emphasize this again. Whether something is a strong acid or a weak acid, it is based on the ability to fully dissociate. For this HCl, because it's considered a strong acid, is because this thing readily leaves its partner into the water and form H plus ions, right? Whereas for carboxylic acids, it's a reversible reaction. Means to say, even though the H plus leaves the partner already, it could form back with the partner, meaning to say the concentration of H plus is much, much, much lower, guys. Yeah, that's the important thing here. And you can use this graph as an example. Every time the pH jumps one time, it will be at a multiple of 10. Multiply 10, multiply 10, multiply 10, 10, 10, 10. And this one here will be divide 10, divide 10, divide 10, divide 10, 10, 10, 10, 10, 10. Yes, everyone? Anyone got any questions for this part here? Okay. Yeah, one more thing I want to emphasize also, guys. This color here, right, is actually almost no way around it. The only common trend that I see is going to be red and blue only for acids and alkali. You will have to memorize it, but honestly speaking, sometimes I forget about the color as well. But once again, you guys are the one going for the exam, so please memorize everything. Huh? What? I don't know. Don't ask me this kind of questions. I can't answer you. Okay, but anyways, please memorize this. For chemistry, it's very different from physics in the sense that there are literally a lot of yes, you will have to as well. For litmus paper or what? Wait, I'll share you a picture later on. I have a picture for everything else that was inside. But yes, you do have to memorize it. Okay. Yes. I think nothing else much to talk about for this part here. Oh, this part is extremely important. Look at this one here. Guys, because acid is considered a H plus, right, which is essentially just a proton, right? So that's why acids are considered to be proton donors. Sometimes in your exam, right, they'll ask you to define what an acid is, or they'll ask you to define what a base is. If they ask you to define an acid, it's very straightforward. You will just say that acids are proton donors, whereas bases are proton acceptors. This is important. This one here, I see it come out in your exam all the time. You have to remember this. You have to, this one you can associate a little bit because you remember the acids is H plus, right? And H plus is essentially a proton. So whenever they dissociate in water, they are donating the proton into the water, right? That's why acids are considered to be proton donors, whereas bases is the exact opposite, right? Instead of donating, they are accepting, guys. Yes, that's why we don't call it a proton. Call it H plus only. Okay. But in general, our definition are proton donor and proton acceptors. Yeah. Let me see what else is important. I think nothing else is important here. You have to remember this. This one extremely important. Then the concentration part, like I mentioned just now, whether it can fully dissociate or not is important. They may occasionally ask you this as well. Everything else you can read yourself. Nothing much here. Yeah, and finally the last part here. I wanted to say this, I forgot about it. Carboxylic acid, ethanoic acid. Yeah, guys, look here, guys. You see, just now I mentioned, right, whether something is a strong acid or weak acid is dependent on whether they can fully dissociate or partially dissociate, right? Sometimes this will come out in your exam as well. So you might want to put a little highlight here as well, right? A strong acid is something that can fully dissociate in aqueous solution or water, whereas weak acids can only partially dissociate in aqueous solution or water, right? You look at the equation here, then you can have a better understanding of why hydrochloric acid is a strong acid, whereas ethanoic acid, which is a carboxylic acid, is considered a weak acid. If you look at this equation here, right, you see as soon as this thing, right, touches the water, fully dissociate, it will turn everything into H plus and it will turn everything into Cl minus. Whereas for carboxylic acid, you haven't learned about this yet, but you just remember that this is called a carboxylic acid, guys. For carboxylic acid, right, you see, it's a reversible reaction. Meaning to say, right, although I put this ethanoic carboxylic acid in water, some of the H plus will be dissociated, but sometimes it could combine back with its partner. Meaning to say the concentration of H plus is definitely going to be much weaker. You understand what I'm talking about, guys? And because of that, you need to remember that the difference between weak and strong acids is just the dissociation of water. Dissociation of H plus ions in the water. Either it will completely dissociate or it will partially dissociate.
Right.
Yeah, nothing else much to talk about here already. Yes, anyone else has any questions for this part here or not? Okay, please read through everything, guys. I've highlighted everything that was relatively important that comes out in your exam. Please take like 5 to 10 minutes to read through the whole note, and then once you're done reading through everything, which will help you in the answering here later on. Guys, please read through everything and let me know if you have any questions. If you have no questions, you can start attempting the ABC questions already. That we're gonna finish with the questions today. And don't lose my paper. We'll continue this paper next week. Please read through everything, guys. and start doing your question once you're done. With everything.
I didn't want to.
When do you do it? Just now? Oh. You're done for the day? Yeah, but anyways, it's a really easy and straightforward chapter lah. Just now, what indicator do you say that I missed out in the notes? Oh my God, the other one that I cannot spell. Fair, North, Lane. Oh, this is the titration one, right? This one is the...
Our teacher said that this is going to come on them.
This one just pink only, or this one. So
That is on the color.
yeah, this one usually for titration to see whether it is neutralized or it's going to turn into a alkali solution already. I have a set of colors that I can send to you guys. Where is it? Okay. Where did the picture go? Oh, here. Guys, I've sent this into the group chat. You will most likely need to use this as reference once again, but yeah, I think only the top three is commonly asked. Everything else is...
Teacher, you see, it is not even produce orange, and his name is Metal Orange. Scamming us. Better scammer than better. Very nice.
Yes, Eugene, are you done? Sorry? Yeah. Yeah. Just pay attention to the top three, guys. The bottom three will not be in your syllabus. Are you guys done?
That old woman. That old woman, did I just that old woman? Pretty sure I saw a hand there. Teacher, do you play games?
Not anymore, sadly.
Well, games?
No.
Oh, you tell it. Oh, yeah.
It's not much, but they feel like you will. I think that's the job you will say. They should go to the
Oh, there's already game, I see it.
Guys, please finish until you see the next set of notes, guys. You have like probably another 15 minutes to attempt the paper. Huh? If I remember correctly, it was gray in color. And wait a minute, don't you guys play? Hello. What? Which one? But it doesn't matter, right? What color the paper is. We usually look at the end product, right? Whether it's going to be acid or base, right? But if I remember correctly, I played with it when I was in high school. I remember correctly, it was gray in color. If not, yeah, I remember it was gray in color. But it doesn't matter. They won't ask you the color of the litmus paper without reacting to it with something.
The content is not here.
Oh, that's fine. So it's a one. Well, that is it.
Is my day.
For what? What's that?
No, hit the grass, no, up to your face, the balloon, no. No one to your feet. The shit. This thing.
Okay, shut up, boy. Hmm?
Oh, base is always,
Yeah.
base.
Alkali is a sub, what's it called? It's a subgroup of base. So if let's say this is a base, right? Alkali will always be inside here, but not all bases are alkali.
What's that? I don't know, it's a little bit of that include. Okay, the acid, correct, so that's how it happens. That's how I like. That's That's actually until the end. Without me. No point. Please don't get it.
We gotta get in there.
That's all the things. That's the way we chose the world. Sorry.
Are you waiting for my answer? What's your answer? Donkey, ah? Why donkey? Why donkey? What's your answer? Huh? Boy, ah? The answer is boy. Hmm? Hmm? I'm trying to figure out what this NH4NO3 is. Ammonium nitrate. Ammonium nitrate. So it's between this and this only, actually.
Why?
Sodium carbonate. Is it considered a base though? I'm wondering why it's not. Hmm? A or C? Are you serious? A or C?
Why?
What's this?
Oh, wait, yeah, that's it.
What's this? Why can't it be? It's 100% not A or C. Sodium carbonate.
So you're dead. Oh, you're now you're there. Oh, this is
Oh, damn. Hey guys, this is a very good question, man. Hey guys, look here. I was wondering why this was not an answer here. It's once again the understanding of carbonates, right, guys? So right now is this scenario here is that it actually is reacting with acids, right? Whatever this substance that you put in with the acid here, it will turn this damn litmus paper, universal indicator blue, which is an indicator that is an alkali solution, alkali in nature, right? Guys, when I put this with what's it called, the acids, what's going to happen is because there's a carbonate in it, right? Ultimately, the final product will be the salt, the water, and also carbon dioxide, right? And because carbon dioxide, once again, is a non-metal oxide, guys. This one here is actually slightly acidic, which is the gas that is responsible for turning this indicator, damn universal indicator, right? So because this is slightly acidic, it will not turn it blue. That's why this was out of the question already. And thus B was the answer in this scenario here.
Oh. Oh. This guy.
Teacher, is it like after it goes to neutrality, it just stays at neutrality, or like it's gonna continue?
Depending on whether it's a reversible or non-reversible reaction. But most of the time it's non-reversible, then it'll stay neutral.
But it's this.
Don't know.
The same question.
It's almost as if you only move when I move.
Look, if they neutralize, it's just become neutral.
Yeah.
Sorry, God. Chemistry God. You gonna have. I didn't know. I thought it's. Come on.
What's your answer for this one?
It's
Huh?
no, because I just go on the question and you just started filming, so I just watched it.
Oh.
I wonder how. Perfectly fine acids.
This one? Which of the following element forms an oxide which can use to neutralize alkali solution? So first and foremost, I want to have what kind of oxide? Acidic or alkali oxide? If I want to have an acidic oxide, what kind of oxide should it be? Metal or non-metal? There's only two non-metals here, right? Either nitrogen or helium, right? Helium can form oxide or not? Cannot ah. Why not? Yeah, it's a noble gas, can't form oxide. So the only thing is nitrogen oxide, which will be an acidic, and it will be used to neutralize the alkaline.
That will. Then this one.
Haven't read it yet. Let me read it first. Exercise of paper 2. I got past year papers, yeah. Can. Wait a minute, didn't we do it? I'll send it to you later. Until which chapter are you? Hmm.
How long does the testing process be like within?
Depending on the amount of subjects you want to, we're planning for it to have 1 hour 15 minutes per subject. So it'll be like a normal Saturday like this.
अभी के लिए discussion.
Yeah. What was your answer for number 1 just now? B. Nope. It's the exact opposite. It's donkey. You see, for this one, right? This thing dissociates the H plus ions, right? So first and foremost, I know that it's definitely going to be acid already. But then I look at it here right now, this is going to be the acid ion. And then this thing combines with this thing to form this thing. Also means to say right now, this thing is acting as a base, right? You get what I mean? This thing dissociates, it turns, it has itself plus a H plus ion. This time, this here, it acts as an acid. But right now, this time here around, it actually combines with the H plus ions, meaning to say this must be the base for it to combine with the H plus ions, right? You get what I mean? Guys, have you learned about the term amphoteric before? You guys know what amphoteric means? You're going to be tested on this later on as well. Oh, maybe it's in the next chapter. Oh, yeah. Oh, it'll be in the next chapter. So maybe that's the reason why you couldn't do question number 1. Never mind. Huh? Yeah, donkey. But just to give a quick understanding, guys, some oxides, they'll behave like acids and also base. They are known as amphoteric oxides. If you take this amphoteric oxide and you react it with a base, it will act as an acid. But if you take this amphoteric oxide and you react it with an acid, it will behave as a base. It has dual characteristics on it. Oi, what have you guys done? Keep playing with your damn phone. Or you're waiting for me to answer only?
Really for hints.
Shut up lah, do your damn works. One more time I see your phone, I'm gonna take it away.
Since no.
Wow.
Isn't that out? Right?
Yeah, it was 1,000.
Go back.
The concentration of AC, right?
Yeah.
Yeah.
Guys, anyone not done yet with this? Anyone besides these two not done yet for the ABC? You know? Which question are you at?
Go.
Oh my God, scared me.
Bash. Download boards. Yes. Those are. Yeah. Oh, those are. This one must be a hundred made. So I did this also. I'm from site. So. I do. Most of that is all the I did. Yeah. It's part of the so. As if it's so over and E. It's very Officer, sorry. Copper for that copper chloride. Copper chloride salt. Cop. What?
Go.
I think that's the solid. I think the tires, no? But is it not? Not all.
Yes, it is.
Imitating my role model.
Huh?
It is.
Oh, it's solid.
Correct. It is salt.
See, yeah. Who are these those? So,
It's not really a application. It's so flow.
no, this one.
No.
See, something.
Good.
I'm sorry, no, but why? What we should I also you know from the city did the oil sulfate and usually
Okay.
this kind of front two sulfates. Still something that means both of them are sister. We have to do for it.
But
See sulfate. Sorry or not.
sugar, bro, metal, sulfate.
Don't forget because why beer? It's not because this two something and this one also.
Is it?
I never knew.
Why see? Alright, yes. Doctor all guess one.
This the see the this the no when they both the same kind so be it That means this one heat from. This will be C.
I want to ask you, what is this, KOH, what is this?
That's a. I know, sorry.
Which is acid or base?
Yes.
Okay. This one,
I will drink nothing. Wait, no.
sulfuric acid. Acid, right?
Yeah.
Base and acid, what was it form? Base, acid, I just said right,
It will. This acid. Water.
water and
Salt.
salt, right? Isn't this the water? Isn't this the salt?
That's
So how come this is wrong?
Because it's like decomposed. So it's too.
Okay, I know already. I know this is correct. I know this is correct. I also know this, but what's wrong with this equation?
Yeah, different from this two.
Shut up lah! Shut up lah! This one I already know. This is correct. This is correct. This is correct. What is wrong with this equation? Huh? Why? This is what?
I don't know.
Who is going to?
Calcium carbonate. Carbonate, right? This one next.
Nitric.
You don't know, you don't know how to refer to the front. We've been literally talking about the same thing over 3 times, bro. Then this is the carbonate with an acid. What are the 3 things that will form just now? I said base, the carbonate. Okay, now you refer to look in front and then tell me what are the 3 products that will be formed. And hydrogen. The only thing that is not there is hydrogen.
That's the case. Oh.
Water, salt, and
I will just say.
so right now this is your what? This one eh?
So.
This one eh? Water.
This is
So what's wrong with this equation?
water.
Yes. Hey, I see some of you guys are not done. I'll just finish it out.
Yes.
Remember, we start the answers next week.
Please don't forget the answer. How does answer to that?
We'll send the detail later in the group.
Yeah.
No, bro, 1
This year.
see. Okay, let's look at it one by one. Here's what? Metal oxide, right? So it's not. Okay, space. This one. Like CL, we're talking about this. What is it? Oh, base acid. What's the salt? Oh, water and salt, right? So what's wrong with this? This is the salt one. This is a metal chloride, right? It's mentioned now. And just look at this. KOH. Obviously a base already, right? But what OH there? This is what is this? Look at it. Base acid. So we form again. What salt and water? You see the metal and the non-H plus, which is the acid, the non-H plus component. Right, this not right. Combined with it, this is the salt, right? And water is the same one. So base, acid, water, salt. This is correct. This is so correct. This one, here's what? Metal, acid. I say what? I said salt. Ash, right? This is correct. So what's wrong with this equation? Here's what? Wait, CO3 is not I like this, right? No, only hello. Only good. That's it. This carbonate and acids. No, what are the 3 products that form this kind of mentioned? You go to the front. It's literally in front if you flip the page. What are the three products that will be formed?
Water is you really want here. Water, salt, so the sun. So that's why.
This one is the salt, right?
Yeah.
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 So then we can I think we look at this question because actually this is something that I was to look at next week. You see, I look at the first instance, that's not even answer the donkey.
No, I at first I found answer E, but I forgot how I found answer E. So what's the answer? I found I know I found the answer just now. I forgot and I tried asking C. How is C for C?
Okay, this is something we learn which is known as amphoteric. Amphoteric is to say it's from space and also intensity, depending on what you mean. But we look at this equation here. The first equation this thing will plus an acid turn into this thing, right?
So let's say once again, right?
So right, thinking about it logically, this must be basically right. The base and acid form together and react together, so it's something. Right? Now look at like this thing now. I don't know what this thing is, but as soon as it touches the water, it dissociates H plus ions. So this thing must be an acid, right? Look at yeah. How are you in chemistry in school? I think theory.
Well, you only have one of the like I didn't. I was like,
Because I keep hearing the word chemistry queen.
no, I said chemistry king.
So look at chemistry and so wait.
Business.
If you don't know any, please try. I'm not going to
So
if not, this is gonna be a rough time because hey, but then same class. Which story seems to oh. But then we are a bit ahead because it's actually for the not very prerequisites.
Your chapter 4 is actually such like in chapter 7 what I'm still in actual sense.
Oh, but it's not chemistry and they don't fall very that point. No, don't worry, not prerequisites and good. So I will discuss the answers next week. If you have any question you want to ask it on. Okay guys, we'll stop here today. For those who are not done, finish it up and we'll discuss the answers next week.
Oh, you never
Sorry, but any question you want to ask? You got any questions you want to ask before you go? Okay, good. See you. Guys, bring the paper back next week. I will discuss the answers.
It won't be.
Welcome. See you. Bye-bye.
I did not see my visa for that one. I said so one reason she does not do one woman. You have a maintenance contract, you still have. That's all.
Goodbye, Lynn.